Saturn, this gas giant, millions of miles from Earth, has always been a cosmic enigma. From its hexagonal North Pole pattern to mysterious space downpours, it keeps scientists on their toes. But now, there's something new in the mix, and it's raising eyebrows. Astronomers are concerned about the future, a time when Earth's inhabitants may miss out on Saturn's majestic rings. What's causing this disappearance, and what's lurking among those rings? Let's find out. The journey of unraveling Saturn's mysteries began with the Pioneer 11 spacecraft in 1979. These were the first close-up glimpses of this celestial giant. But it wasn't until 2004, with the arrival of the Cassini mission, that scientists truly began to unveil the wonders of this ringed world. As we continue our studies of Saturn, it occasionally reveals its well-kept secrets, reminding us of the vast unknowns that surround it. Saturn, the solar system's second-largest planet, boasts a unique characteristic. It has a core that's about half the planet's radius, weighing a whopping 12 to 20 times the mass of Earth. And here's the mind-boggling part. If you had a reservoir big enough, Saturn would float in water. That's because its density is only about 0.687 grams per cubic centimeter, making it the least dense of all the planets in our solar system. But Saturn's distinctiveness doesn't stop there. While most planets in our solar system appear nearly spherical, Saturn is the flattest of them all. It's a speedy spinner with an orbital period of approximately 10.5 hours, causing it to bulge at its equator and flatten at its poles. Picture it, Saturn measures about 75,000 miles in diameter at its equator and spans roughly 68,000 miles from one pole to the other. And have you ever admired Saturn's striking yellow and gold bands when viewing it from Earth? Those are the result of superfast winds in its upper atmosphere, clocking in at an astonishing 1,100 miles per hour. Imagine gazing at the sixth planet, and what do you see? A colossal hexagon pattern, roughly 20,000 miles wide. That's truly bizarre. This immense, intricately crafted hexagon shifts from blue to golden hues, adding to its mystique. Now, courtesy of Cassini's high-res images, we've got a treat. This hexagon hides a colossal hurricane right at Saturn's North Pole. It's gigantic, surpassing Earth's hurricanes by 50%. Reddish vortices spin around it, moving in sync with the hexagonal jet stream. Here's the twist. The composition of particles inside and outside the hexagon differs. Inside, smaller haze particles rule, while larger ones are scarce. Outside, it's the reverse, and the hexagon's persistence is astounding. While Earth's hurricanes last a week or so, this one has endured for decades, maybe centuries. How does this monster storm form, you ask? Deep thermal convection, a fascinating phenomenon, generates it. Heat passing through fluid or gas triggers atmospheric flows, creating large polar cyclones and an eastward jet pattern at high latitudes. When these features combine near Saturn's upper regions, you get the striking hexagonal shape at the North Pole. And the bonus mystery? Spokes across Saturn's rings. They appeared during the Voyager mission, but vanished during Cassini. These streaks look dark from above, but bright from below. We're still stumped about what causes them, but they reappear seasonally, just like our Earth seasons. Saturn has its own timekeeping, with each season lasting about 7 Earth years. The spokes might originate from dust particles separating from icy chunks and floating independently above the rings, possibly influenced by Saturn's magnetic field. Saturn's mysteries, from hexagons to spokes, are truly mind-boggling. Saturn's rings are its standout feature, and although other gas giants in our solar system have rings, Saturn's are the largest and most distinct. These remarkable rings are divided into 7 main ones. The rings, named in order of discovery and positioned along Saturn's equator, are the D ring, C ring, B ring, A ring, F ring, G-ring, and E-ring. They begin roughly 4,300 miles from the planet's core and extend outward for an astonishing distance. For some perspective, let's take the E-ring, for example. It spans a mind-boggling distance of about 75,000 to 260,000 miles. To put it in context, imagine a road stretching across the entire length of Saturn's E-ring. If you were to drive continuously at a speed of 100 miles per hour, it would take you over 2.5 months to travel from one end to the other. Now that's a vast expanse. But that's not all. There's also the tenuous Phoebe ring, which extends approximately 100 to 270 times the radius of Saturn. Much like Saturn's distinctive shape, its rings are astonishingly flat. While certain areas of the rings can reach a thickness of approximately 0.6 miles, the main rings are incredibly slender, measuring a mere 32 feet in thickness. There's also the idea that one large moon collided with Saturn's largest satellite, Titan, in the past. Computer simulations have identified a potential moon named Chrysalis, which was similar in size to Saturn's third largest moon, Iapetus. Saturn and Neptune's gravitational interactions caused Saturn's axis to tilt and wobble in sync with Neptune's orbit, leading to the changing angles at which we observe Saturn's rings. Titan's gravity played a role as it moved away from Saturn, destabilizing Chrysalis's orbit and causing it to approach Saturn and get torn apart by its gravity. The stunning ring system we see today is believed to be the remnants of Chrysalis. So, how old are Saturn's rings? Recent studies estimate their age to be approximately 100 to 400 million years. However, their days are numbered. Under the influence of the Sun's radiation or plasma clouds caused by space rock impacts, Saturn's majestic rings are gradually melting away. In about 100 million years, they will disappear, becoming a celestial marvel of the past. But before they vanish, they have an intriguing impact on Saturn's atmosphere. Dust particles in the ring sometimes become electrically charged and disturbed. When this happens, the particles bind to Saturn's magnetic field, which draws them inward toward the gas giant's upper atmosphere. As Saturn orbits the Sun, its rings and the planet tilt, altering the radiation exposure on its inner ring layers and affecting the intensity of the icy ring rain. NASA reports that Saturn's ring system is depleting at an astonishing rate, losing an Olympic swimming pool volume of water every 30 minutes. Recently, after 4 decades of research, scientists revealed that this cascade of ring rain pouring down onto Saturn has a significant impact on the planet's atmosphere. Each second, an astounding amount of up to 6,000 pounds of icy particles gracefully descend onto Saturn. As these particles make their atmospheric journey, their accumulated energy is transferred to the surrounding environment through collisions with other particles. This energetic exchange contributes to Saturn's atmospheric heating and may cause glowing bands in the planet's northern and southern hemispheres. But Saturn's rain doesn't stop there. Enceladus, one of Saturn's moons, shoots jets of water ice into space from its underground ocean. Some of these tiny particles are influenced by Saturn's magnetic field and gravitational forces, causing them to rain down onto the gas giant's atmosphere. This phenomenon is aptly named moon rain. Now, while Saturn's ring rain is a cocktail of chemicals, including organic compounds, it alone isn't enough to support life. But what about Saturn's moons? Could they hold the key to discovering extraterrestrial life? Saturn has recently reclaimed its title as the king of moons in our solar system, boasting a grand total of 145 satellites. However, 2 of these moons have scientists particularly intrigued: Titan and Enceladus. Both of these celestial bodies possess ingredients that could be essential for life. Let's start with Titan. Known for its thick atmosphere and abundance of organic molecules, including complex hydrocarbons, building blocks for life. Titan's atmosphere resembles that of a planet, primarily composed of nitrogen. What's fascinating is that Titan has rivers, lakes, and seas on its surface, but they aren't filled with water like on Earth. Instead, they contain methane and ethane, compounds associated with the metabolic processes of many organisms as sources of energy. Although Titan's harsh conditions, like freezing temperatures around -290 degrees Fahrenheit, make it seem inhospitable for life as we know it, scientists have proposed an alternative possibility involving a molecule called acrylonitrile has the unique property of potentially forming stable and flexible structures akin to cell membranes, creating thin, sheet-like materials. These sheets could then shape into small, hollow spheres called azotosome, which resemble lipid bilayers and could act as microscopic containers for storage and transportation. What's intriguing is that the ALMA Observatory has detected significant amounts of acrylonitrile molecules in Titan's atmosphere, up to 2.8 parts per billion. Researchers believe that over time, enough acrylonitrile could have reached the surface of Titan's lakes, such as Ligeia Mare, to create approximately 10 million azotosome in every milliliter of liquid. To put this in perspective, it surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water found on Earth. In 2027, NASA's Dragonfly drone is set to launch, and it will provide a comprehensive examination of Titan, bringing us closer to understanding whether life could potentially form on this celestial body. Thanks for watching, and make sure to leave a like and subscribe to the channel so you can stay tuned for the latest breakthroughs in space exploration.